Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, we are going to see how to find the inverse Laplace transform. Last class, we have seen how to find the Laplace transform of division by t and Laplace transform of periodic functions. This lecture, we will be seeing inverse Laplace transforms. If you are perfect in Laplace transform, we can easily do the inverse Laplace transform problems. Say if Laplace, we know that Laplace transform of f of t is f bar of s. This can be written as f of t means L inverse of f bar of s. So, f bar of s is any frequency domain, we apply L inverse, we get the function in t domain, that is time domain. What is Laplace transform of e power 3t? We know that it is 1 upon s minus 3. So, if we simply apply L inverse, so this can be written as L inverse of 1 by s minus 3, that can be written as e power 3t. So, simply if you are perfect in Laplace transform, we can easily calculate inverse Laplace transform. Let us see one example. Find L inverse of 3s minus 8 upon 4s square plus 25, right. So, using linear property, we can write this as L inverse of 3s by 4s square plus 25 minus L inverse of 8 by 4s square plus 25. So, this can be written as, this 3 is constant, let us take it outside, L inverse of s by 4s square plus 25 minus 8 is constant, let us take it outside, L inverse of 1 upon 4s square plus 25. So, this can be written as, denominator let us take 4 common. So, this can be written as 3 by 4 into L inverse of s by, when we take 4 common here, this can be written as s square plus 25 by 4, that means 5 by 2 whole square minus 8 into L inverse of 1 upon, here also let us take 4 common, s square plus 5 by 2 whole square. I want to write this in the form of s square plus a square, that is why I have taken 4 common in the denominator. So, this can be written as 3 upon 4, this is in the form of L inverse of s by s square plus a square. So, this is L inverse of s by s square plus a square, it can be written as cos a t, here a means what, 5 by 2. So, cos 5 by 2 into t minus, this is 4 ones 4 twos, 2 into L inverse of 1 by s square plus a square. Here we have one formula, L inverse of 1 upon s square plus a square can be written as 1 by a sin a t. We apply this formula, here a means 5 by 2. So, this can be written as 1 by 5 by 2, that is 2 by 5 into sin a t, sin a t means sin 5 by 2 into t. So, this is how we evaluate the inverse Laplace transform. Let us see now inverse Laplace transform using partial fractions. This partial fractions we might have covered in lower level, intermediate level. Let us see how to find the Laplace transform of such functions. Say for example, find Laplace transform of s minus 2 by s square plus 5s plus 6. So, to apply partial fractions, s minus 2 upon s square plus 5s plus 6 can be written as a by this s square plus 5s plus 6 can be written as in fractions, I mean in s plus 2 into s plus 3. So, this can be written as a by s plus 2 plus b by s plus 3. This also can be written as s minus 2 by s plus 2 into s plus 3. Since this can be written into linear factors, we write using partial fractions. Now, let us find the values of a and b and substitute in this equation and apply inverse Laplace transform. So, to find the values of a and b, this can be written as a into s plus 3 plus b into s plus 2 divided by s plus 2 into s plus 3. Here s minus 2 by s square plus 5s plus 6. So, both are cancelled. When we substitute s is equal to minus 3 plus 3, a will become 0, we get b value, minus 3 plus 2 is minus 1. So, substitute both sides s equal to minus 3. So, minus 3 minus 2 is minus 5, it is equal to b into s plus 2, s means minus 3 plus 2 is minus 1. So, minus cancel, we get b equal to 5. Similarly, to find the value of a, we take s is equal to minus 2, substitute s equal to minus 2 both sides. So, we get a value as minus 2 is minus 4 is equal to a into s plus 3. S means what? Minus 2 plus 3 is 1 into a plus 0. So, a value we get it as minus 4. Substitute a and b values in equation 1. So, we get this can be written as a means minus 4 upon s plus 2, b means 5 upon s plus 3. We find L inverse of this function. What is L inverse of this? Also can be written as 4, we take it outside, L inverse of 1 upon s plus 2 plus 5 into L inverse of 1 upon s plus 3. We know that L inverse of 1 by s plus 2 is e power minus 2t. So, this can be written as 4 into e power minus 2t plus 5 into e power minus 3t. This is how we evaluate using partial fractions. Let us see one more example. Find L inverse of s plus 2 by s square minus 2s plus 5, or else let us take one more example. Find L inverse of s square plus 2s minus 4 divided by s square plus 9 into s minus 5. To apply partial fractions to this, first of all, we write s square plus 2s minus 4 by s square plus 9 into s minus 5. To apply partial fractions, this can be written as a by s minus 5 plus s square plus 9, we cannot write it into factors. So, we write it as bs plus c by s square plus 9. Here let it be equation 1. We have to find the values of a, b, c. So, this can be written as a into s square plus 9 plus bs plus c into s minus 5 divided by s minus 5 into s square plus 9. So, like this we find these values s square plus 2s minus 4 by s square plus 9 into s minus 5. By simplifying this, we get the values of a, b, c. A value we get it as 31 by 34 and b value we get it as 3 by 34 and c value we get it as 83 by 34. Substitute a, b, c values in equation 1 and find the inverse Laplace transform. So, L inverse of s square plus 2s minus 4 divided by s square plus 9 into s minus 5. This can be written as L inverse of, here a by s minus 5 is there, a value is 31 by 34. So, 31 by 34 into s minus 5 plus bs plus c, b means what, 3 by 34. So, 3 by 34 into s plus c means what, 83 by 34 divided by, this is also L inverse by s square plus 9. Further we want to simplify this. So, this can be written as L inverse of 31 by 34, let us take it outside, L inverse of 1 by s minus 5, L inverse of 1 by s minus 5, right, plus here 1 by 34, let us take it common, L inverse of s by s square plus 9 plus L inverse of 1 by s square plus 9, this 83 by 3 into s square plus 9. So, 3 by 34 into, what is L inverse of 1 by s minus 5, e power 5t plus 1 upon 34 into, this 3 take it outside, L inverse of s by s square plus a square, here remains 3. So, this can be written as cos 3t, 83 by 34 into L inverse of s square plus a square, 1 by s square plus a square is 1 by a sin a t, here a means 3t. So, this is how we find the inverse Laplace transform using partial fractions. Now, let us see how to find inverse Laplace transform using partial fractions, using first shifting theorem, Already we have seen how to find the Laplace transform using first shifting theorem. In inverse Laplace also we will apply first shifting theorem. Let us solve this one example. Find inverse Laplace of s plus 2 upon s square minus 2s plus 5. We will solve this using inverse Laplace using first shifting theorem. Denominator, if we can see, s square minus 2s is there. So, this can be written as, first write down the denominator where we will apply s square minus 2s. Is this we get in s minus 1 whole square or s minus 2 whole square or s plus 2 whole square? In which expansion we get s square minus 2s? Is s minus 1 whole square. If we expand this x minus 1 whole square, we get s square plus a square minus 2ab. So, s square minus 2s we are getting. Here we have plus 5. So, if you add plus 4 to this, we get s square minus 2s plus 5. So, this can be written as s minus 1 whole square plus 4. Since you are writing this denominator in terms of s minus 1, we write numerator also in terms of s minus 1. So, this can be written as s minus 1 plus 3. Now, it is easy for us to apply first shifting theorem. This can be written as, we split this s minus 1 by s minus 1 whole square plus 4 plus L inverse of 3 upon s minus 1 whole square plus 4. To apply first shifting theorem, this can be written as e power plus t into L inverse of 1 by s square plus 4 can be written as 2 square. 3 write it outside, L inverse of 1 by s square plus 4 multiply with e power t. So, e power t into or e power t, let us take it common. L inverse of 1 by s square plus a square is 1 by 2 sin 2t plus 3 into L inverse of 1 by s square plus 4 is 1 by a sin a t, 1 by 2 sin 2t. Right. Let us see one more example. How to find L inverse of 3s minus 2 divided by s square minus 4s plus 20 using first shifting theorem in inverse Laplace transform. This can be written as L inverse of s square minus 4s. These two terms will be in expansion, s minus 2 whole square. So, here s minus 2 whole square can be written as s square plus 4 minus 4s. Here we have s square minus 4s plus 20. So, this can be written as s square minus 4s plus 4 plus 16. So, s square minus 4s plus 4 means s minus 2 whole square plus 16 can be written as 4 square plus 16, that is 4 square. Since we are writing this denominator in terms of s minus 2, numerator should also be in terms of s minus 2. So, this I will write it as 3 into s minus 2. So, 3s minus 6. So, 3 into s minus 2 means 3s minus 6, but we have 3s minus 2. So, if we add plus 4, we get this. Now, let us split this using linear property. L inverse of 3 into s minus 2 by s minus 2 whole square plus 4 square plus L inverse of 4 by s minus 2 whole square plus 4 square. Using first shifting theorem, we write it as e power 2t. Since it is s minus 2 is there, we multiply with e power 2t. L inverse of 3s by s square plus 4 square. Here also 4 into L inverse of 1 by s square plus 4 square. This e power minus 2t, let us take it common. So, e power 2t into 3, write it outside, L inverse of s by s square plus 4, that can be written as cos at, a means 4 here, plus 4 into 1 by s square plus a square, 1 by a sin at. So, 4 and 4 get cancelled, e power 2t into 3 cos 4t plus sin 4t. This is how we find the inverse Laplace transform using first shifting theorem. Next lecture, we will be covering inverse Laplace transform of different functions, first shifting theorem, second shifting theorem, and etc. Thank you.